Welcome back, Math 30-2 to Lesson 9, Part 2 on logarithm scales. So we've looked so far at our earthquakes, and we looked at sound loudness. And we noticed that they were increasing always by 10 times. The count was always by 10. Now we're going to look at pH, and we're going to notice the exact same thing. It's almost the exact same thing as the other. So if you didn't quite get those, this one might help you understand it a bit more. It's only slightly different, this one here. Okay, so as we go here, it has our pH scale and our concentration of hydrogen. Okay? If we notice, the water is 10 to the negative 7. The pH is 7, that is 10 to the negative 7. When the pH is 14, that's 10 to the negative 14. Okay? So right here, we are increasing our alkalinity, and here we are increasing our acidity. So this is more basic, this is more acid. Alright? So as we look at it, the higher concentration of hydrogen, H+, the hydrogen moles, will create more acidic. And the lower concentration creates more basic. Okay? Things will become more basic, or they will be more alkaline. So complete the following approximations here. So right now we're just going to try our best to complete these following approximations. So a tomato juice is how many times as pure water? Acidic. So let's look at tomato juice. My tomato juice is right here. It's 4, is a pH 4. And now we're going to look at pure water. And our pure water is 7. So in this case, it is 4 minus 7. So if I went 4, subtract 7, that gives me negative 3. But negative 3 here is actually an increase. So that's really 3 increase. So this is 3 increase. So that's 10 to the 3 bigger, which is a total of 1,000 times bigger. Okay? That's the only part where this one gets a little bit confusing. I'm just going to move this over a bit so we can see it better. Okay? Now, let's take a look at the next one. It says eggs are how many times more alkaline is base, than pure water. So it's the opposite direction. So we take a look here. We have eggs down here, and then pure water. So they are 1 more alkaline. So they are 10 times more alkaline. 7 minus 8 is 10. So they're 10 times more alkaline. Okay? In this case, we might even want to switch it for the top one. We could have said 7 minus 4, because we always go the more acidic, subtract the less, or the more base, subtract the less acidic. So if you want to think it that way, this one's going to be 8 minus 1. So eggs are times as acidic as pure water. So now we're going to look at eggs to pure water. How many times more acidic are eggs than pure water? Well, that's the opposite of what we were doing before. So it's going to be 10 to the 7 subtract 8, which is negative 1, which is 1 over 10. Okay? Now the last one here, we're getting closer. Milk of magnesium is 1,000 times greater than what? So, as blood. Is it 1,000 times? So let's look at blood, it's 7.5. Milk magnesium is higher. So it is more alkaline. So it's higher alkaline. So it's higher. It's more alkaline. It's higher base. Okay. Now let's take a look at this last one. What is 100 times more acidic? So acidic is going to be this way in the chart. We want 100 times. So that's 10 to the 3. So we want a different 3 as rain. So normal rain is 5. We want it to be more acidic than normal rain. And we keep on going up. And I get vinegar, sorry. So that's 100 is 2 zeros, so that's 10 squared. So we're going to end up getting rain and vinegar. Now eggs are 1/10,000th is alkyne. So if they're looking at alkyne, eggs are here. We want something more on the acidic side. So going this way. So eggs, and we want something more acidic, so that's going to be a lower pH. And how many is this? There's 4 zeros, so it's 4 lower. So that's going to be tomato juice. Okay? Because it is 4 lower. There are 4 zeros, and it's -4. So we want something that's 4 less. That's tomato juice. So as we look at our alkyne, it's greater, acidity is smaller. Okay? There we go. Now, let's take a look at this next one here, which is pure water in a swimming pool and seawater have pH levels of, so we have pure water, swimming pool water, and seawater. These are their each. This one is the swimming, or pure water is 7, swimming 7.5, and 8.4 is the seawater. Now it says the seawater is how many times as alkyne as the pure water? Well, we know this is going to be 10 to the, if I want to figure this out, I want to have 10 to the, and we're looking at seawater, and alkyne is base, so we're going to do base first. Seawater is 7.5, and we subtract, I think we want seawater as pure water, subtract 7. Okay? Oh, seawater is, 8.4. So we have 8.4, subtract 7, which gives us 10 to the 1.4, which ends up giving me a total of 25 times more acidic. Or more, not acidic, more basic. The alkalinity. Okay? So seawater is how many times as alkyne as swimming pool water. So now we're looking at seawater to swimming pool. And we want to know seawater to swimming pool. So that we go again, it's going to be 10 to the seawater. 10 to the, where's my seawater, is 8.4. And we want swimming pool water, which is 7.5. That's going to give me a difference of, that's going to give me 10 to the 0.9, which gives me a total of 8 times. Okay? So now let's take a look at our last question here. In our last question, we're going to use this formula. They normally give you that formula on your provincial diploma. So it will be given in the question when you need to use it. Just know that H is your hydrogen ion concentration. And if we notice, the more acidic it gets, it's the negative, okay? It's that way. Because our power is always to the negative something. It's 10 to the negative something. So that's why there's that negative in front. If you want to go over it, I could go over that with you a little bit more tomorrow. So a patient gave a urine sample which found pH of 5.7. So you know the pH is 5.7 is equal to. Now he wants to know the hydrogen iodine concentration. Negative log the negative logarithm of my hydrogen concentration. So now we have to solve for this hydrogen. So how do I do that? This is saying 10 to this negative. I could put this negative on this side and make that positive, couldn't I? Multiply both sides by -1. Okay? And I make that positive if I multiply both sides by -1. So I'm going to get 10 to the negative 5.7 is equal to H. So I end up getting, if I put this in my calculator, 2 times 10 to the 2.0 times 10 to the -6 moles per liter. Okay? So let's try the last one. This one is giving us our concentration in moles. So I know my pH is equal to negative log, and we have 3.4 times 10 to the -4. That's it. Now I just have to put this into my calculator, and I'm going to end up getting 3.5. Because it was giving me my H3+. So I plug this in for my H right there. That's how we do that. If you have any other questions on this one, hopefully you'll contact me tomorrow and you'll ask me about it. Thank you, and I'll see you tomorrow.